Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Assalamualaikum dan selamat sejahtera. Okey, dalam video ni saya akan terangkan tentang superposition of wave. Principle of superposition of wave states that when two or more wave meets at a point, the resultant wave is given by the sum of the displacement of the individual wave at each point in medium. Okay, y equal to y1 plus y2. Y is the total displacement. Y1 is displacement of first wave, Y2 adalah displacement of the second wave. Okay. So, kita tengok graf ni. Okay. Dekat satu point yang sama. Okay, kita tengok dekat satu point yang sama. Kalau kita nak tahu dia punya total displacement dia berapa, kita kena tambahkan dia punya displacement of first wave dengan displacement of second wave. So bila kita tambah nanti jadi macam ni. Okay, so dia dekat point ni kan. Then yang first wave kita 3, second wave kita pun 3. So kita punya total displacement of the construction wave dia akan jadi 3 tambah 3 sama dengan 6. Okay, sama juga yang bawah ni. Yang bawah ni sama juga. First wave kita negative 2.7. Second wave kita displacement untuk second wave kita adalah negative. Total displacement for resultant wave kita adalah hasil tambah kedua-dua wave ni ialah negative 6.7. Okay, next ialah wave interference. Wave interference is the phenomenon when two waves meet while travelling along the same medium to form a resultant wave of greater, lower or same amplitude. Okay, so dekat sini kita ada dua jenis interference. Yang pertama ialah constructive interference dan disruptive interference. Constructive interference. The vertical displacement of the two pulses are in the same direction and the amplitude of the combined waveform is greater than that of the either pulse. Constructive interference form when a crest of wave met another crest of wave or a through of wave met another through of wave with the same frequency at the same point. So it will form a new wave with greater amplitude. Maksud dia dekat sini, constructive interference ni dia terbentuk apabila crest bertemu dengan crest ataupun through bertemu dengan through dekat point yang sama dengan frekuensi yang sama. Okay, crest bertemu dengan crest kan, so bila dia overlap dia akan produce new wave dengan larger amplitude. So kalau kita nak tahu dia punya ni berapa, kita tambahkan dia punya amplitude tu, sama macam yang dah terangkan tadi. Disruptive interference. One pulse has a negative displacement while the other pulse is positive displacement. The two pulses tend to cancel each other when they overlap. The amplitude of the combined waveform is smaller than that of either pulse. Disruptive interference also form when a crest of a wave met a through of another wave with the same frequency. So, it will produce a new wave with lower amplitude or zero amplitude. Maksudnya, disruptive interference dekat sini, dia akan berlaku apabila crest bertemu dengan through dalam frekuensi yang sama. Jadi, bila dua wave ni overlap, dia akan produce new wave dengan lower amplitude ataupun zero amplitude. Okay, bila kita tengok graf ni, yang biru dengan yang peach ni, dua-dua ni ada same amplitude, tapi yang biru ni dia move to the right, yang peach ni dia move to the left. So apabila dua-dua wave ni dia overlap, dia akan produce standing wave. Sama macam yang dekat bawah ni. Okay. Perkara yang kita perlu tahu ialah yang pertama, node. Node is defined as a point at which the displacement is zero where the disruptive interference occurred. Okay, tengok dalam gambar ni. Tempat yang disruptive interference berlaku, kita panggil dia sebagai node. Okay, then second, antinode is defined as a point at which the displacement is maximum where the constructive interference occur. Okay, antinode ni ialah amplitude yang paling maksimum. Okay, dekat tempat yang paling maksimum tu, dekat situ kita label as antinode. The pattern of standing wave is fixed, hence the amplitude of each particles along the medium are different. Thus, the nodes and antinodes appear at particular distance and determined by the equations of the standing wave. Secara ringkasnya, point of zero displacement ialah node, point of maximum displacement is antinode, distance between two consecutive nodes or antinodes is lambda over 2, the distance between two consecutive nodes and antinodes is lambda over 4. Lambda is 2 times distance between consecutive nodes and antinodes. Okay, standing wave equation. Consider two progressive waves of the same frequency, amplitude and velocity but travelling in opposite direction. Okay, so dekat dalam equation ni dibagi y1 and y2. Beza y1 and y2 ni ialah dia bergerak dalam opposite direction. So kita tengok dia punya formula ni ada sedikit perbezaan. Yang y1 a sin omega t plus kx plus 2, maksudnya the progressive wave move to the left, and y2 a sin omega t minus kx. The minus there means the progressive wave move to the right. Using the principle of superposition of wave, the resultant wave is the summation of the displacement of wave. Okay, kita tambahkan displacement of first wave and the second wave. Displacement of first wave kita a sin omega t plus kx, and displacement of second wave kita ialah a sin omega t minus kx. From the identity trigonometry, we know that sin A plus minus B equal to sin A cos B plus minus cos A sin B. When we solve the equation, finally we get the y equal to 2a cos kx sin omega t. This is the standing wave equation, okay, where the 2a cos kx is the amplitude of standing wave at any x value. A is the amplitude value of the individual progressive wave. 2a is the maximum amplitude of standing wave. A cos kx used to determine the amplitude for any point along the standing wave. It is called the amplitude formula. Its value depends on distance x. Okay, so formula A cos kx ni kita guna untuk determine dia punya amplitude untuk standing wave. Okay, then sin omega t used to determine the time for antinodes and nodes will occur in the standing wave. Okay, then kita sambung dengan soalan pula. Soalan pertama, transverse wave travel along a stretched string at speed 130 meter per second and frequency 250 Hz. Standing wave are produced on the string. Determine the distance between A two consecutive nodes. Okay, kita tahu distance untuk two consecutive nodes, formula dia ialah lambda over 2. Tapi kita tak ada nilai lambda, so kita cari dulu nilai lambda. Gunakan formula lambda equal to V over F. Masukkan velocity dengan frekuensi dia, nanti kita dapat lambda equal to 0.52 meter. Then kita masukkan dalam formula lambda over 2 untuk cari distance between two consecutive nodes. So kita akan dapat jawapan dia 0.26 meter. Okay, then soalan B ditanya a node and an antinode nearest to it. Okay, so distance between distance antara node dengan antinode. Okay, yang kita tahu distance antara node dan antinode, formula dia ialah lambda over 4. So kita masukkan dalam formula lambda over 4 tu, then kita dapat 0.13 meter. Okay, untuk second question, two sinusoidal wave y1 and y2 travelling in the opposite directions interfere to produce a stationary wave. y1 sama dengan 6 sin 600t minus 9x, y2 equal to 6 sin 600t plus 3.9x, where x and y are in cm and t in s. Okay, so A, find the maximum displacement of the particles in the medium when x equal to 0.15 cm. Okay, so daripada soalan ni, kita susun balik soalan ni. Kita cari dulu amplitude dia apa dia punya omega dia, apa dia punya k. Okay, dan kita daripada equation ni kita dapat tahulah amplitude dia adalah 6 omega, dan k kita adalah 3.9 radian per cm. Okay, dan kita masukkan dekat dalam formula standing wave, y total equal to 2a cos kx sin omega t. Dan formula standing wave kita adalah 12 cos 3.9 x sin 600t. Okay, then soalan A, dia nak maximum amplitude. Okay, kita tahu formula untuk amplitude ialah 2a cos kx. So kita masukkan nilai yang kita dah ada dekat dalam formula 2a cos kx ni. Kita akan dapat 12 cos 3.9x. Then dia ada bagi tahu when x equal to 0.15. So kita substitute 0.15 tu dalam formula, then kita dapat maximum amplitude dia 12 cm. Okay, then B, find the position of nodes. Position of nodes ni maksudnya zero displacement. Okay, so position of nodes kita ada formula dia. Bila dia zero displacement, maknanya amplitude dia 0. So 2a cos kx equal to 0. Then kita pindah-pindahkan, lepas tu kita masukkan nilai k, then kita cari x dapat. Nanti x dapat 0.402 cm, 1.208 cm and 2.014 cm. Okay, C, calculate the speed of this wave. Okay, speed of wave. Kita tahu speed is velocity kan, so v equal to f lambda. Lepas tu tapi kita tak ada f, kita tak ada lambda, so kita guna balik formula itu. Okay, kita masukkan f, sama dengan omega over 2 pi, dan lambda is 2 pi over k. Then kita substitutekan nilai dia, dan kita dapat speed dia ialah 153.83 cm per second. Okay, so next, okay, based on the diagram, which position will the overlapping wave have the most construction interference? Okay, kita tengok diagram ni. Okay, so first wave kita yang red line tu, then second wave kita yang color yang yellow. Okay, have the most construction interference. Construction ni maknanya crest bertemu dengan crest ataupun throw bertemu dengan throw. So kita tengok dekat position mana yang construction. So bila kita dah tengok, kita dapat jawapan dia dekat position 2 and position 3. Okay, then B, at which position will the overlapping wave have disruption? Disruption maksudnya apabila wave crest bertemu dengan throw. Okay, so jawapan dia position 4 and position 5.
Assalamualaikum and hi. I am Zahara from S15P11. During this video, I will explain topic 10.3 sound intensity. Sound intensity is defined as energy transport per unit time, sound power P, across a unit area. From this definition, we can get an equation I equal to E per T over A. E is energy, T is time, and A is area. Energy per time is equals to P, sound power. So, we can substitute and get the equation I equals to P over A. The unit is watt meters power of negative 2 because power is watt and area is squared, meter squared. Okay, so this is the unit. From the equation I equals to P over A, we get the relation: the greater the distance from the source, the larger the area which a given amount of sound energy is spared, and thus the lower its intensity, which means the further the observer from the source of sound, the lower its intensity. Sound intensity is perceived by the ear as loudness, which means makin kita jauh dengan sumber bunyi tu, makin perlahan bunyi yang kita dengar. Next, we will proceed to 10.3b, depends of intensity on amplitude and distance from a point source. The relation between intensity of sound is proportional to A squared, where A squared is represent amplitude squared. So that means the higher A will produce a higher I. This small amplitude correspond to low energy wave will produce a low sound intensity, while large amplitude correspond to high energy wave will produce high intensity. Okay, next we have the intensity of sound is inversely proportional to the square of the distance from point source. Okay, we can get this equation I is inversely proportional to R squared. So we can conclude that if we have a low R squared, we can get the high intensity of sound, which means makin kita dekat dengan sumber bunyi, semakin kuat bunyi yang kita dengar. Okay, remember the previous equation, I is equal to P over A. Okay, sound travel to all direction. So basically, we consider it's move in shape of a sphere. The area of a sphere is 4 pi r squared. So if we substitute it into the equation, we will get I equals to P over 4 pi r squared. Okay, this equation will be used in a few questions that I will show. Okay, here we have two graphs. The first graph is I against R squared graph. So from this we can see the relation. If we have low R squared, we have a high intensity of sound. It means the distance is close to the source of the sound. Okay, it's inversely proportional to the R squared. Next, we have a straight line graph of I against 1 over R squared. Okay, it is same with the previous graph. This is okay. Okay, we have a few questions. This is the first question. Write down the information we get from the question and the equation of sound, intensity of sound. Okay, but the problem here, we don't have the area. We just have the distance. So, kita guna area of a sphere divided by r squared. Substitute into the equation and can get I is equal to P over 4 pi r squared. Then substitute the value. We can get P equals to 5089 watt. But they ask for the energy. We got the energy from the equation P equals to E over T. We have the T, right? Here, for every 1 second. Substitute into the equation and we will get P equals to E and tulis balik jawapan. Okay, ini jawapan. 5,089 watt. See? Okay. This is a second question. From this question, keluarkan maklumat dan kita akan dapat R1, R2 and I1. Kita juga tahu dia datang daripada sumber yang sama, a baby cry. Alright, next. We can solve the equation with this equation. I equals to 1 over R squared. Datang daripada relation between R and R squared. They are inversely proportional to each other. Rewrite the equation and cancel the P because they came from the same sound source. So we can cancel the P and 4 pi. We arrange the equation and we will get this equation. Let I2 be the subject and get this equation. I1 darab R1 squared over R2 squared. Substitute the value and get the answer. This is the answer. Jangan lupa tulis unit yang betul. Okay, this is the third question. From the question, keluarkan every given information and don't forget to change 1 hour into SI unit of time, that is second, and then write down all the information and we can get this much of information. We must find the power first. Okay, the intensity of sound is I equals to P over A. Substitute the value we have and we can get the power 6.7 times 10 power of negative 8. We arrange the equation. Let the E energy be the subject and substitute all the value we have from the earlier solved equation. And we will get this answer. Right into 2 decimal 2.42 times 1 degree. Okay, this is the question. This is the answer.